Hi, everybody. This is Kubernetes work group device management meeting for May 7th. This is an ad hoc meeting to go over some APIs. And um, so I hope this will be participatory. Also, I hope that some of you will sign up for some asynchronous work afterward. Um, so basically, we have an existing API in 130 for DRA. Um, and we knew even when we did that in 130 that the model that we were coming up with wouldn't be quite sufficient for all of the use cases we have. So what we've been doing for the last couple of weeks is kind of brainstorming what this model would look like from 2 points of view. One is like, can we evolve the existing model, and how would we evolve that? And we'll talk more about that probably next week. And the other is kind of taking a step back and saying, okay, if we try to meet a few other goals, like simplifying, reducing cognitive load, because there are quite a lot of objects in the existing model, things like that. Like how little can we do to get away to still meet the use cases, right? And I think we've narrowed use cases from the original design of DRA to some extent, so that also might give us a little more flexibility. So the proposal here is just that, a proposal. Let's think of this as a brainstorming session. We're trying to evaluate a bunch of different possible APIs. We've probably been through 5 or 6 versions of this already to get to where it is that we're showing you. And we even after all of that, last night as I was going through it, I found kind of a fatal flaw in exactly how it is today that we're going to have to fix probably today, come up with some solution for before I ask all of you to help contribute to evaluating the model. When we evaluate the model, the things we're looking for, and I don't know, Tim, if you have additional things, these are the things that come to mind for me. Expressiveness, that means if I have a requirement, a use case, something that I need out of this platform, out of this system, can I express those requirements in my API? Implementable, right? As the people trying to implement what we express, we got to make sure that we can do so, and we can do so, without sort of unbounded scalability issues or whatever it may be, and that we can do so within the constraints of the existing platform. So we have certain versioning rules that are there to protect our users. We have certain conventions that are there to reduce the cognitive load and make things work the same way across different APIs. So we got to make sure that we can implement the API we present within those constraints. And the third one is the user experience. So this is super important to me. Like, I feel like this gets down to cognitive load. It's as a user, for the thing I do most often, is it super easy? And things I don't do very often or that have complex requirements, I'm okay with those being more challenging. But I do want to make sure that for the most common use cases, it adds minimal complexity. And then lastly, that it feels like a natural extension of the existing Kube APIs. So that's also a cognitive load thing. Like if this one API works differently, then you can't take the lessons you learned from elsewhere to it. Do you have anything to add to that, Tim?
When it comes to APIs, most people don't care what the API is. We as engineers tend to think about elegance, and most people don't really care what the API is as long as it works and they can find the documentation on it. That said, I want to emphasize what you said, that the common things, the things that people are mostly going to do, should be the easiest things to do. And if that comes at the cost of the relatively niche use cases, I'm okay with that. But trying to find a way that makes the simple path simple is the most important.
Okay, thanks, Tim. I see a hand 77777.
Yeah, that's me. I had problems joining in. This is Patrick. Hello.
Oh, okay. Hey, Patrick.
That's fun.
Yeah, I guess I
Oh,
don't
good.
possible
Kevin's here
that's
too.
the name. Yeah. So I want to put that into a little bit into context to what I've been doing in parallel. Some of you may have seen on the Slack channel that I've been posting incremental updates to the CAP. So this is another approach or another attempt to simplify the API. Both are basically, ideally, perhaps at some point, meeting in the middle. I don't know whether we'll get there, but I've been taking some ideas of things that John has been trying out. Simplifying nesting in the YAML files, for example, is something that I have in one PR pending. Renaming the named resources to devices is another thing that completely changes what it looks like in YAML. So I just want to point out that this is also an option. And I think our goal is to just look at all the use cases that we have, write them down as YAML side by side so that we can compare how it looks when using one API or the other. And then we'll see which one looks good, feels right, is expressive enough, and all of that.
Yeah,
it does have it does have a slight problem that we are now currently at this point splitting our resources. Poor Kevin has been asked to look at both proposals at the same time, and I think we're overloading him. So this is where others who are familiar with the API design and have been using DRA probably can help, because you understand use cases, you know how a YAML file looks like that uses DRA. You can write down some of the use cases for the existing DRA, and you can wrap your head around the new proposal and see whether it still works for you. So these, I think, are the people that we are looking for, right?
Yeah, exactly. Thank you, Patrick. Yeah. So exactly what Patrick said, like we're going to go through this one now, but the idea would be gather these use cases over the next few days. And I think I'm happy to meet with folks and how, and actually go through that. And then we'll try expressing those use cases in both of these models, both of these APIs, and see what they look like. So that's what I mentioned when I said we'll hear more or see more about the evolution approach tomorrow, or not tomorrow, next week. But ultimately these converge, and we figure out. We're just trying to figure out the right shape. So with that said, are there any questions? My next step here, what I'm planning to do, would be to actually look at the code and some examples. Then what I guess the ask is of the folks on this call, ask as many questions as you want here. Oh, I'm sorry. I should be sharing my screen. Yes, sorry about that. I'm seeing it. Sorry. There's too many. There we go. Okay. Sorry about that. Yeah, I had this, and hopefully you were looking at the agenda on your own. I had this kind of criteria in here for how we should think about our API evaluations. You're seeing my screen now, right? So the next step will be to go into the actual APIs. And what I was saying is that any input we get during this meeting, wonderful. But also we'll set up a Slack channel or a thread. We'll start a thread where anybody can ask questions. But what I really like folks to do is, I guess there's multiple tiers of getting involved here. One is, hey, I can just make a statement. Here's my use case is I need to be able to get 2 GPUs that in aggregate have this much memory, and I need to get a NIC card along with it, and I need to get a local volume along with it. right? Like, so that would be, and those should all be, on some constrained intranode topology. Now, we might not be able to do all of this today, but what I want is to get all of those use cases. So one is just make those statements. That could be a collection of a bunch of statements that we come out of this with. The other is, and we can evolve those together by meeting or on Slack asynchronously. The other is a step deeper, which is, I have this use case. Now I want to try and write the YAML for it. What would it look like? And so that's from what I call a claim side. Or we call it claim side. That is the user facing side. We also have capacity side, which is from the device vendor. So I know a few of you on here, I hope, are people who represent device vendors. And we have a model or an API to represent different types of devices. And we want to make sure that's expressive enough. Now, things like the usability of that become a little less critical than the expressiveness, because it's a smaller set of people who need to do it, and they're sort of more deeply involved. But nonetheless, all of these same considerations come into play. So with that said, let's jump in here. This should be linked here. As I said, we have two different types of APIs here. One is from the end user perspective. That's the claims that you want to make. It's the requests from the platform for devices, and how to associate those devices with your workload. And that's the one I'm going to go through first. So let's drill into it. So like many other APIs within Kubernetes, we have a concept of a class and a claim. A class is an administrator provided resource, or the vendor of the device often will supply a set of default classes, but an administrator, a cluster administrator, platform administrator can also define them. And the class just sort of specifies general properties, or it's an equivalence class of devices. It's like a pool, not a pool, it's a bad word. It's a, it's a set of, in this particular case, it's specifically a constraint which defines the driver that manages that device. So like if NVIDIA has a driver, you'd say, I'm going to have a class called NVIDIA GPU, and the driver would be specified to NVIDIA's driver. So then in the claim later, when the user asks for something, they could ask for an NVIDIA GPU. They know they're getting something that's managed by that driver. It also has a constraints field. So this allows the administrator to put further constraints based upon some attributes, and we'll see what that looks like later. And finally, it has config objects associated with it. So if the vendor releases a CRD that helps describe the configuration of their device, then they can you associate that with a class. So then you can ask for a type of a device that's configured in that way. What might be more helpful, I'm starting to drill like into the detailed Go files, but maybe it would be more helpful to look at a few examples of what a pod spec might look like. So let's start real simple. In this model, the idea, right, is that the pod spec makes the claim. In the DRA in 130, we have resource claims, and in the pod spec, you can list your resource claims, and then in the container spec, you can reference back to the resource claims, very much like volumes. And this is the same thing. We changed it to device to try to narrow the scope, although that's something that's under discussion whether we should do that or not. And in this particular case, in the interest of trying to make the most common case as simple as possible, we have a way within the device claim list to just ask for a class name. And that means give me one in one type of device that's part of that class. So in this case, we have a class defined called a Fuzor GPU class, and all it does is say it's anything with that driver. That's the spec. You can ignore the metadata for now. So simple case simple, we have a pod, it has a container, we want to give it one Fuzor GPU. We just have to list that. There's some weird YAML structure here, but basically we just have to list that one piece of information, the name in the claim, and associate it. Why does it keep doing that to me? Associate it back to the individual container. So if, on the other hand, we have one container and we have two GPUs, we have to have a little bit more complicated form. And this, again, gets to these constraints that are within our API versioning system. We have to limit what we add to the pod spec just to as little as possible. So instead of putting a bunch of stuff directly in the pod spec, we reference another object. This is exactly how 130 works, just slightly different names and slightly different structures. We have a reference to a claim or a claim template in the existing one. In our case, we just use a claim. And we ask for a device class Fuzor, but we ask for two of them. Does that, are folks following so far? Or I guess if you're not following, please feel free to raise your hand and I will stop. All right. So,
I mean,
So,
so
sorry,
just
John,
one thing to throw in. Oh,
go ahead.
I was just going to say, at a high level, the only difference I see so far is the ability to reference a class directly without having to have a claim, which we can't do today.
in the pod spec construction, the pod spec construction in existing DRA has a claim source, but this is the area of it's not quite working. So I don't want to like there's some problems with it as far as being able to express certain kinds of constraints, and we'll see that in a minute. So we will end up changing it. But in the existing DRA 130, the claim source is basically a template name or a claim name. I tried to make two additional changes to that. One is you can have, I got rid of the template top level object because it's basically identical to the claim top level object. It's just used differently. I don't know if that's a good idea or not. I think it's something we should debate. There's a sort of desire to reduce number of top level objects, but also using things sometimes as a template and sometimes not is kind of confusing. So I'm not sure which is the right way to do it. But in any case, in order to simplify that use case and not have to create two objects in order to use this at all, and just be able to specify something directly in the pod spec, I'm stretching the generosity of the API reviewers to try to see if they'll let me reference just a claim directly. So this is a class directly. This is to be determined whether this will be implementable in the constraints of the API versioning mechanisms.
John,
So-
I have a tangent question. You showed me the example of where we can refer these devices under the container spec. I know we have a requirement in the networking to be associated to the pod spec instead of like a container. Do we have an example for that?
So basically, you just don't have to list it with any container at that point. So if you go
so
back,
then it becomes a, okay, got it.
yeah, because you're already in the pod spec, and so you're already associated with the pod. So at that point, it's not required for network devices to mount them into a particular container, and so they just, yeah,
Yeah. Okay. Sounds good. Thanks. I missed that information.
The other thing I added here, Kevin, was what we talked about yesterday, was the idea that, hey, maybe I have some vendor specific controller that generates claim specs, and I had a way to reference that. This is very speculative at this point. I don't know that we should spend much time on this.
Yeah, let's ignore that for now.
So I also want to be clear that the goal today isn't to like ratify this API, right? It's to evaluate it as a different expression of the problem and to see if there are places where we can simplify. Like Patrick said earlier, meeting in the middle is a great outcome. This is sort of a radical, like, what if we threw everything out and cut it down to the bone? I appreciate that because it forces us to sort of rederive some of the requirements. One thing I hope to get out of today is some excitement about crystallizing the most important use cases into the simplest expressible form possible. Because right now there's so many use cases and so many what ifs that I struggle to figure out what's real and what's hypothetical. And which ones, even of the real ones, which ones are really important and which ones are really sort of not important.
Yeah, thank you, Tim. Let me actually look. I probably deleted it. So I have. So I had a set of examples, and even if we don't look at the details of them, we can look at the. We can look at the descriptions of them, because it might give you an idea of the flavor of things we would like to understand from a use case perspective on the claims. I guess I shouldn't have merged that last. I think it's what deleted this file. Okay. Wait, are we in this? This is just going to give me the commit, isn't it? Of course. All right. Well, I'm not going to spend time trying to. I could just pull it up in a shell, but yeah, maybe I should do that. Sorry. You know what? Let's just continue with what we were doing. I don't want to take people's time to try and find my way around my machine, because it's actually on a different machine. I'm going to have to do a lot of work to make it all happen. But I do have, and we can go through some things later with folks who are interested in the kind of claims. Like I had in this test data directory a few examples of like, okay, I want to get one container, 2 GPUs, 2 containers with 1 GPU. What would that look like? So here's 2 containers sharing a GPU. You have the 2 containers, the GPU is listed here, and they mount the same GPU twice. If I want 2 GPUs in 2 containers, then I can list, device claim Fuser GPU 1, other Fuser GPU, and then I can mount those specifically here. And here, this is exactly how it works today in our existing one from the claim spec perspective. Where we start to get some interesting things is in constraints between devices. So we'll get to that when we get to the when we look through this API. Yeah, I shouldn't have deleted a file I deleted, and now it's a little bit hard to show you examples because it wasn't up to date. But, okay, so we talked about the class. The class is defined by the administrator. The selector, so a class can define which driver is going to be used. That gives you one class of devices. You can define additional constraints like model or things like that, defined in this cell constraints expression. So each device, we'll see this in the capacity model, each device is going to publish some demographic information, static metadata about the device, like its model number and things like that. Maybe it's a driver, a firmware version, something like that. And you can add those sort of things in your constraints cell expressions. And like I said, you can add configs. So that allows you to be pretty specific about, I want an NVIDIA GPU, but there are use cases around things like, particularly things, non-GPU things where they're less, where they're more universally understood. So like SRIO VNICs, we don't care whether we get an Intel one or a different one, Mellanox one or whatever. That SRIOV works basically the same way across all these vendors. They have different drivers because they may need to be configured differently, but from the point of view of my pod, I get an interface mounted into my pod that's an SRIOV interface. So the question was, if my class directly embeds a driver and says that and Intel has a different driver than some other vendor for their SRIOV NICs, then when I want an SRIOV VF in my claim, I'm going to have to specify Intel SRIOV. And that's going to limit me to only those nodes that are running and have those Intel NICs in them. And that's not what I want. So the class definitions were too prescriptive. So in order to work around that, we've tried a few different ideas. And the one we've landed on so far is that you can have a class that actually defines a group of classes. And it does that via a label selector. So you'd have a class called SRIOV NIC, and it would in turn use a label selector to select a set of classes, all the classes with that for SRIOV NICs that are regardless of vendor. So what that looks like in an example, actual example, we see here in our classes example. So you have, let's go to those. Here we go. This defines an SRIOV class, a class for SRIOV NICs from the example.com company, but it adds this device type label for SRIOV NIC. If we had a example.org company that made SRIOV NICs, they could create a class and they would also have device type SRIOV NIC. So this becomes a label that we need to agree on. But then I can define a class that only selects on that device type. So it's a class that selects other classes. So now my claim just says, I want an SRIOV NIC. My scheduler can say, that means any one of these 5 classes. So now you can do, it narrows my set of nodes to a broader set than if it were one of those classes. So this is how we would express vendor neutral types of devices, is through sets of classes. All right.
Sorry, I just had a question about that. I know you already navigated. Oh, Abhishek, sorry, you have your hand up. I just realized.
Oh, I didn't see what the hand was up. I can't always tell, so please, yeah.
Oh, yeah. I mean, I have 2 questions. The first is I would like to see, where we specify a GPU sharing strategy. And then since we are talking about SRIOV, is there a way to select a NIC from the multiple NICs that could be present on a server? For instance, a concrete example would be you want to select an RDMA NIC over a normal PCIe based NIC. So how do you do that?
Great questions. Okay. What was the first question? Great questions, but I forgot.
The first was where do you specify? Where does the user specify GPU sharing strategy? Okay,
so we have two places you can hook. That would come into configuration. And we have two places you can hook in configuration. So the class has a configuration object associated with it, but classes are only controlled by administrators. So the administrator would have to create a class of this type of GPU with this sharing strategy, and they would associate that object with it. You also have config associated with the claim. So that's what these arbitrary config objects are. And the way this works in practice is you would define a configuration CRD. You'd associate that with the class. It's a kind of a lazy binding thing. So once a pod comes along and says, I need a GPU of this class, and they may associate additional config with it if they want, then once that GPU gets allocated, it gets those configurations. And so if you're going to end up sharing it with another pod later, that pod has to have the same configuration objects. Essentially, the GPU gets configured, and that makes it a special little type of GPU in its own with that configuration. Am I making sense, or am I getting too detailed here?
I think the way I would describe it, John, if I understand correctly, is that today what we do is we bundle selection and configuration into one CRD, which is our claim parameters object. And what you've done is you've pushed selection directly into the class or the claim itself. And configuration still needs to be a separate CRD, but that's where you hook it in, is one of these config slices.
Yeah, yes, exactly. And so, but the understanding or expectation is that if you have two different claims with two different configurations, they can't land on the same device. They can't be satisfied by the same device. Whereas if you have, in the sharing case in particular, if you've got a given claim or class with really a claim, because it's an aggregation of the claim and class configuration. If you've got a given claim and the configurations are identical across those claims and subject to our other sharing constraints within the API, you should be able to service them with the same underlying device.
Really? That's very different than what we will do today. So that we need to talk about that, because that doesn't match my understanding of how this should work. So
Okay, well, we'll have to discuss that, because otherwise you can't share, right? Once you configure, you can't share. So if you set a sharing setting, you can't share other than through user-mediated sharing. So I differentiate between user-mediated and platform-mediated sharing, and I'm talking about platform-mediated sharing when I talk about that. And this is a subject we're not even sure. Like, this is exactly the kind of thing. And sorry, Patrick, I see your hand. I do want to get an understanding from this community whether Kevin has specific use cases for user-mediated sharing. What do I mean by that? It means pointing the multiple pods at the same claim, and the user has to do that, or a higher level workload controller. Then there's platform-mediated sharing, which is I make two claims, and each of those claims, completely independent people could be making these claims. They are able to be satisfied using the same underlying device because those claims basically have indicated a willingness to share a device. That's the platform decides if and which devices might get shared in that case, and we have to have ways to mediate that. So I'm not sure. I've heard vaguely of use cases for platform mediated sharing, and it's essentially what we do today with nodes. And it's, I think, important if we want to increase utilization of these GPUs. So, but I haven't seen a concrete use case for it yet, and that's something I would love to get from this follow-up from this discussion. Patrick.
So I think one thing that stood out to me is indeed this implicit sharing that probably Kevin also stumbled over. If I understood it correctly, if two claims happen to reference the same configuration, they may end up using the same resource, just because the match criteria is the configuration. Perhaps I misunderstood. This seems very implicit and potentially error prone, because if you have two claims that are basically just by accident have the same configuration requirements, perhaps the user didn't want them to be shared. But perhaps that's a misunderstanding. We'll need to look into that.
Yeah, there needs to be an indicator, and I'm not sure I have it in the API right now. There needs to be an indicator that you're willing to accept sharing or not, right? That's granted. You don't get sharing unless you explicitly opt into it.
My other question is, you seem to rely heavily on predefined device classes. Do you have an understanding of how many of those you might need in a cluster? How do you communicate to the user which class they should be using for which purpose? This kind of, I'm a bit worried that this gets out of hand. If you have different configuration options that may or may not be set, and you all try to capture that in a class, you end up with an exponential combinatorial explosion of different classes that all need to have some kind of descriptive name, because different users might all need one of those different configurations. I wonder what we have thought about that.
So,
Also,
that's
related is, how do you get consistency across clusters? Is it now the job of the vendor to define what classes and which configurations should exist so that users don't need to learn about this cluster has classes A, B, C, and they correspond to classes X, Y, Z in another cluster?
I agree on all counts. There is the expressiveness in the API there's nothing you can do in a class that you can't do directly in a claim other than set the driver. So at a minimum, you would have one class per driver, and you could do that, and you could just get away with it. And then maybe if you have things like SRIO VNix, which are vendor neutral, and you want to be able to access them as a pool, as a unit, a class, you might have those meta classes. But beyond that, you don't actually need to create any classes. And I would be open to, in that case, if we think that's what we really want, just literally get rid of these, right? We don't need those anymore. All we need is driver and that's the minimizing. And we could add those later if people are like, there's not enough in the class. On the other hand, I get specific feedback from some people saying, whoa, my end users aren't going to understand how to specify all this complex claim stuff. I, as a platform administrator, want to create a class that's way more complicated than what you see on the screen in front of you. I want everything I can do in a claim, I can do in a class, and then I can just hand that off to the user. So that's the kind of feedback exactly that I want to get from this group, because I only hear, everything's filtered like through multiple layers, and I'm hoping we have some platform admins and some end users we can get some real concrete feedback on. I totally agree with you there, Patrick. That's a real concern. I don't know the order of hands, but please just self-regulate. Yeah.
Urush was before me.
Yeah. So about use case, and maybe Kevin can also comment on this, but like one use case is that, for example, NVIDIA Nickel, let's say that they have one pod or container for each rank, right? And then to run NVIDIA Nickel, I need to expose all GPUs to all containers in order for each container, each rank, each GPU to discover other GPUs as being local to the node. So in that case, this whole machinery has to essentially expose one GPU as an active GPU, another as like a discovery mode GPUs. And like I was hoping that device plugin could kind of solve this, but do you think this is feasible? And like how do you see this as an option?
Yeah, I haven't
I'm not
thought
sure I understand.
much of the,
Okay.
yeah, I haven't thought too much about the nickel use case, but yeah, we should think about that. But let's not derail this conversation to go into the details of that specific use case. Maybe me and you can sync offline.
Okay, great.
Yeah, and go ahead and put your name down, Ruth, in the agenda. What I'd like to come out of this meeting with, because we really only have 20 minutes left, is a list of people we can follow up with who have substantial input. And I do want to say that and this can be, I don't think we want to open this door, but we can talk about it if we really do. We are constraining our scope in this working group to at least in this version to effectively single pod constraints, like, because when you get to multi-pod, I mean, certainly we're constraining ourselves to single host. So when you start talking about trying to get, because we're claiming groups of devices, and then the question is, when we claim a group of devices, how do we select those devices? How do we constrain the selection, and how do such that, like, there's internal consistency, they're all in the same PCIe root or something like that. But once we get to multi-pod, we start getting into where we need to consider multiple pods simultaneously. Now, Kevin has a solution for this in the existing DRA that kind of does a side channel, but I don't think it's generalizable in our existing scheduler. So our existing scheduler is a pod at a time scheduler. If we want to make multi-pod considerations across multi-hosts, we need a scheduler that's going to do that. I think we can get there eventually, but not in this iteration. Patrick, I think you're in response to something that was just said, whereas Tim might be, I don't know. You guys sort out who should talk first.
I'm not sure.
Patrick, if you're topical, go ahead.
Yeah, you're absolutely right. I think we are single pod at this point. Anything else will imply scheduler changes. I wanted to point out that the focus can't be just on node local resources, though, because we do have people who have been waiting for a better way to do network attached devices, not network devices, the things that you access in the cluster. I just want to point out that this is something that people care about. And if we drop it from the API support right now, it's not going to come back anytime soon. So I think we should consider things like an IP camera. That's the canonical example. We have even a DRA prototype for that already from the ACRI project. And they are just waiting for the API to stabilize to roll that out, because what they're currently using are just ACRI hacks. Anyway, this might be a tangent. I don't know how well your current model supports network attached things.
So then those should get written down as use cases, and we try and express them in there. And if we can't, we have to decide whether we should be able to, right? Like, I think that it's been on the bubble in my mind of what we support in 131 is the network attached devices, just to try to bring the scope to something that's achievable. But like I said, it's on the bubble in my mind. And I think you and I talked about, like, you were suggesting some different, I think there were some things you were suggesting that might make it, like, feasible and separable enough that we could do it. But let's just add it to the use cases. I think, again, the goal out of this meeting is, like, I want to recruit people, honestly, to help us contribute to these use cases, because we need concrete, detailed use cases, and we will help you and talk to you and meet with you and go through that and ask our questions to make sure that we understand your use case fully. But I do need to recruit those folks. Tim, go ahead.
I wanted to just speak to the class discussion earlier. We're by analogy, we're extending patterns that we've done in the past, right? Storage classes and gateway classes and ingress classes and runtime classes, because it's a pattern that we think has delivered value for users. If that turns out to not be true here, we're happy to jettison it, right? We should, all things should be on the table here. But it is a pattern that we've seen a lot from administrators who say, I don't want to expose the gory details to my end users. I would like to qualitatively describe my things and let them use it so that they have some amount of portability. I understand that right now we're in a world where end users do know all the details about the hardware they're using. I'm not sure how happy they are about it, but it is the world that we're in right now. And so we need to be super careful not to obscure the information that they need to have access to today, but also make sure that they don't need to have access to that in the future, which is a really tough line to walk. And I'll also say the multitudes of use cases that we're looking at here, as they expand, I don't want two answers to things, but at the end of the day, if we can't fit everything in the same box, we have to think about making a second box.
Yeah. Okay. Awesome. Thank you, Tim. Okay. So moving on from class, we understand what class is. We have claims. So a claim, I'm going to start at the bottom because you can actually have there's a little bit of nesting in claims, and I'll explain why in a minute. But let's start with, I just want a single device, and I want to be able to specify it. So a claim, a simplest claim, right, can just specify a class. I just want, and that gives me one device of that class for my pod. I want to skip this admin thing for now. If, say, though, I want a device and I want it to be a specific model, so I know from my class that I'm getting an NVIDIA GPU, but I really want a specific model of NVIDIA GPU, and I'm only willing to accept that model, and there's no class defined for that because, like we said, we don't necessarily want a proliferation of classes. I can specify in my constraints device.model equal A100, right? And now this claim, so there's just two fields I had to fill out. One was class NVIDIA GPU, one was constraints model A100. The available attributes for that constraint cell expression comes from the device vendor. However, we will, as a community, probably need to define a handful of recognizable things, although often these come into play when you already know the vendor because you've already specified the class at that point. And so they're sort of a finer level. You could even specify things in here like I need this version of the driver or greater than or equal to this version of the driver or those kind of constraints go into this cell expression. Now, a claim by itself can be for a single device or it can be for multiple devices. By default, it's for a single device, but if you want multiple devices, there's kind of two ways to get that. The simplest way is you know exactly how many you want. I want 4. I just put requests devices 4, and I get 4 devices. So we saw that back in our examples. I had an example that said request devices 2. There's another mode, and this is again where I would like to understand how real this is, or is this just something we could do, but nobody's actually going to use it, where you could specify instead of saying I need 2 devices, you could say I can take anywhere from 1 to 4 devices. So requests become devices 1, max devices comes, whoops, max devices becomes 4. So that's specifying in the claim I can take between 1 and 4 devices. How does the scheduler decide whether to give you 1 or 4? I need some other constraint on that. So other thing I need to fulfill, otherwise I'll just give you 1. Well, I say I need between 1 and 4 devices. I need the aggregate memory of those devices to be 64 gigs. So now I've given my scheduler options to satisfy this claim. The scheduler can satisfy it with 1 GPU that has 64 gigs, and you're done. The scheduler can satisfy it with 4 GPUs with 16 gigs each. Either one of those is fine with me. I have no preference. I just need to get the full 16 gigs. So that's what you can. Those are the basic things you can express within a claim for how to grab a set of devices. Now, within an individual claim, to be very clear here, when we're getting these as a unit, meaning they're going to be associated with 1 container. Now, So just to be clear, because this is where we get to be a subtle difference between when we want 2 GPUs for 2 different containers, or we want 2 GPUs for 1 container. It's like we're getting it as a pair. Within a single claim, we're getting it as a pair. Within a single claim, you can specify one more thing, which is the constraints on consistency between those. So I can say match attributes, model. So now I'm saying not only I want between 1 and 4 that aggregate to 64 gigs of RAM, they all have to be the same model, or they all have to be on the same PCIe route, or they all have to be in the same NUMA node. Again, these are attributes we're going to need to define as a community that all the vendors can populate, because later we'll see, not in a single claim, but in a multi-claim situation, you could have cross-vendor things where you need to do these matches. Abhishek.
Thank you for explaining that. And I mean, I'm seeing this for the first time, so pardon my ignorance. But as you were describing about request and max, and the numbers that you used, like 64 gigs and four requests or 4 replicas, like to me, it occurred that I would probably get a 16 gig GPU first, which would be a V100 in NVIDIA parlance, and then as more capacity becomes available, then the next 3 land up, which cumulatively adds up to 4 GPUs of 64 gigs. But I guess the intent here is to give all or nothing. So maybe it's just, to me, it's not obvious that the all or nothing intent is obvious here.
You mean versus it growing over time as things are
Yeah.
freed or something?
Yeah.
That's super interesting. So everything we're talking about here is interpreted at pod scheduling time. And remember, this all goes back. This is not a claim for resources across the cluster. This is a claim to satisfy an individual pod. That's a different thing than like a reservation of resources, which you can then in turn use. That's like a completely different concept. This is literally, I want to run this container in this pod, and it needs these resources. I don't think we have any, we don't have anywhere in Kubernetes, and Tim or somebody correct me if I'm wrong, where we can grow. Like we are working on things like mutable pod resources, but it's not supported today in Kubernetes. Just the same here, the expectation isn't a mutable set of devices associated with a pod. At admission time or at pod scheduling time, we decide these are the specific devices you're getting, or you don't get scheduled. So that's the context. Does that make sense?
Okay. Yeah. Okay.
I mean, it sounds like you have another use case there. I would suggest we write it down. I don't know that this is the thing that's going to solve it for you, but again, like Tim said, it may be another box that we need to build at some point.
Mm-hmm. Okay. Thank you.
Yeah. Okay, so we're running low on time. I will just I'm going to ignore this admin thing. This is a very specialized use case that's mostly of interest to device vendors. But I will jump into this. What we looked at was kind of the details of a specific claim. It's a specific ask for a set of devices. We actually have that. The claim itself is actually a composition of multiple of those. And what does that mean? So those individual claims are specific to a driver, right? So I'm saying I need an NVIDIA GPU or a couple of NVIDIA GPUs. But I also might need, for my workload, my pod, a NIC, right? And a specialized NIC, an RDMA NIC or a whatever, right? So that comes in a separate claim, which is associated with a separate driver. And I need to be able to say, oh, I need the GPU, and I need to be able to say I need the NIC, and I need to be able to say, again, they both need to be on the same PCIe route in order to get the performance I need. And so a claim spec itself is actually a match attributes plus a list of claim instances. A claim instance is either the thing we went over, or it's actually one more slightly complicated thing. It's a prioritized list of claim instances. So this is how I would say and express, hey, my pod needs a NIC, and it needs either an A100, that's my preference, or H100, whichever one's, I don't know, I'm not the GPU guy, because it's A100, yeah. H100, H is better, okay. An H100, or if you can't get me an H100, get me an A100. If you can't get me an A100, get me 4 of this other kind. So I can actually expand among all of those things, whatever you give me, make sure they're all on the same PCIe route. The NIC and all of the 1 or 4 GPUs you give me. So I can express that for my pod. This is to try and help with the obtainability problem, right? Of like, all right, I want what I want, but I can't get it. So I'm going to list my preferences after that. So from a scheduler point of view, right, the scheduler, what it does is it takes this claim and it looks across the field of capacity, identifies all the ways in which this claim might be satisfied. It scores them all up. It's going to score the thing. If it can meet it with the first preference, it's going to score that higher than it can meet it with the second, which is going to score it higher than it can meet it with the third.
If I may, I have one comment from kind of autoscaling side on this. Scheduler scores are generally not considered by autoscalers. This is certainly true for cluster autoscaler, and I believe it's also true for Carpenter. And it's actually not easy to integrate them because you're not looking at one pod, you're looking at basically adding nodes for a set of pods in one go, and it's not clear how you would combine those scores. So I think specifically for specifying priorities, it would be good to have some discussion on how we can do this, so it also works in autoscaled environments. The problem with scheduler scores is if you have autoscaling, more often than not, you're just not going to ever have a choice because in scheduler, because the autoscaler will just provide one type of nodes. And if the mechanism doesn't work with autoscaler, then essentially it's just doesn't work in this type of environment.
Right.
I mean, you're going to get one of your preferences, just not the first one.
Right. And so we might need a different construct for that, but we do have the data, and we're out of time, but in the capacity side, which the autoscaler, the idea is the autoscaler would be able to look at a node shape and see the same capacity the scheduler is seeing, that as what would be created. So you should theoretically be able to evaluate it. You may not be able to score it though, like you're saying. So let's have that. Can you add a note to the agenda, or you and several of us can sync up and try to make sure that what we're doing is going to be feasible for autoscaling. Okay, awesome. Thank you. I know I never got to, I think, to Abhishek's second question, but we are out of time. What I might ask is, Tim, go ahead.
Sorry, I wanted to say, repeat sort of what we said at the beginning. Like, this is an attempt to reimagine how we might describe this problem. If someone out there is watching this, either live or recorded, and thinks you have a different approach, I would love to hear it. Like, this is a brainstorm and there are no bad ideas. Like, come at it from a different angle and see if there's a different way to express this, because this is a really challenging problem with a lot of requirements on it.
Yeah, thank you, Tim. And I will constrain Tim's statement with one thing, which is that we have a substantial amount of urgency. So if you have that idea, bring it. I mean, unless we push it out of 131, right? Like, we have substantial urgency. So let's, bring it quickly if you got it, right? I'd love it. And with that said, I haven't looked at the back of the agenda to see if we can maybe put, if folks can put their names. I'm going to put a little thing here. Follow up. So I know Abhishek had some things he wanted. Maciek, There were some other folks. If you could add your names here, and Kevin, me, Patrick, Tim will try to follow up with folks either in a separate meeting with everybody, or we can do one-on-ones, whatever it is. But this week would very much like to actually sit down and go through and try to understand your use cases in detail. So I hope this has been useful. We didn't get as far as I'd hoped, but let's try to meet up more this week. Thanks so much.
Thanks, John.
Thank you.
Thanks.